In this video I'm going to show you how to find the limits of a rational function. And first let's write our function in factored form. So what can we tell right away just by looking at the function? We know that at -1 and 3 we're going to have discontinuities. But they're not of the same type. At 3 we're going to have removable discontinuity, and at -1 we're going to have a asymptotic discontinuity. So that means that when we're looking for the limit of the function at 3, so that's the first limit. Doesn't matter if we're looking for it from the left or from the right. We would first remove that factor of x minus 3 from the numerator and the denominator and simply find the limit of this function, or of the function written in the simplest form. So once that factor of x minus 3 is removed, the limit is simply equals to the value of the function at the point. So in this case it's going to be 6/4 or 3/2. The same limit will apply for both sides. So there we go. Now, when finding the limit of the function at -1, since at -1 we have asymptotic discontinuity, now we just have to figure out whether it's plus or minus infinity. We know it's going to be infinity, we just don't know if it's plus or minus. So we can use algebra here and quickly construct the sign chart. So the sign chart would look like this, which tells us that to the left of -1 it's going to be negative infinity, to the right of -1 it's going to be positive infinity. If you're not sure how to construct the sign chart, then you can just take a value close to -1 but less than -1, such as -1.01, plug it in, and you can confirm that the number will be negative. For the right side limit, you can take a value 1.01, plug it in, and then you'll see that the output is positive. Since the limits on the left and on the right are not the same, that means the two-sided limit does not exist. Now, what is the limit of this function as x approaches to 2? Since there's nothing interesting at 2, it's neither removable nor asymptotic discontinuity. To find this limit, we can simply evaluate the function at that point. So limit of the function at 2 is the value of the function at 2, which we can find by using the simplest form. So it is 5/3, and it's the same for either left or right sided limit. Now, what about the limits at infinity and negative infinity? Well, we know that this rational function has a horizontal asymptote y equals 1. We know that from the fact that the degree of the numerator and denominator is the same. Therefore, the horizontal asymptote is simply the ratio of the leading coefficients. So since this function has a horizontal asymptote y equals 1, that means that type of behavior can be described using the limits the following way. Limit of the function as x goes to negative infinity is 1. Limit of the function as x goes to infinity is also 1. So this is how you find the limits of a rational function.